Okay, next up is our standard deviation calculation. And this is one where Staplet is really going to save us a lot of work and keep things very accurate. I will say sometimes for expected value, I'll go to the formula. It ends up being a bit faster sometimes. But if we need standard deviation, I'm more inclined to go to Staplet to find that value. But I'm going to go ahead and show you how to find it by hand so that you can work through those steps and show your work as needed. So I provided both formulas up here, the formula for variance, standard deviation. Something to note is these formulas are exactly not exactly the same. One difference is the square root. So that's where I have this little notation. The standard deviation of x is equal to the square root of the variance. So you can calculate variance first and then take the square root to get the answer. Just know that as you break up the steps more and more, you want to keep things super duper accurate. The more accurate you can keep it, the better, because if we round too much in our work, it's going to completely throw off that end answer. Okay, so the pieces here. Let's look up. So we have our big symbol that's telling us to add. That's pretty much telling us to add across the table. So that means we're going to be looking at each piece of the table with the x value and its probability. Note that that symbol's mu right there. That's the same as our expected value. So what we're going to do is some of the pieces are we're going to take our deviations squared. So as a refresher, deviations are where we take our x value and subtract away the mean. So we're looking at the distance between the value we're observing and the average. So deviation squared means take that difference of the x value and the mean and square it. Then we want to multiply by x's matching probability. And then we're going to do that for each outcome on the table. And then we add them up. And then for standard deviation, we take the square root. So that's just kind of writing out our pieces. And now let's get into plugging in numbers, and I'll show you how I kind of organize this into a table to keep the work nice and organized. And then I'll show you in the Desmos Scientific Calculator how we plug that in. Okay, so before we can find standard deviation, we always need to know the expected value. So the mean we found in that previous example there is 47.4. And notice in the sentence, I round to a whole number because that made sense for cups of coffee. But I want to use the accurate value. So what I'm going to do is make myself a little table. I'm going to go ahead and organize those squared deviations. So what that would look like is a squared deviation. We take my x value. So from the table, the first value for x is 30, and we're going to take away the mean and square it. And then I go to the next value, which is 36, minus the mean, square that. And we just want to make sure as we do this that we're including all of those pieces, that it's subtraction and that it's getting an exponent of 2 on it. 7.4 and square that. And then the last one is 60. So that's going to organize my squared deviations. And then what I want to do is I want to multiply each of those by its matching probability. So each of those calculations is going to get multiplied and then by the probability that went with that column. So I'm really kind of looking at 30 had a probability of 0.05, and 36 had a probability of 0.2. 42 had a probability of 0.25. 48 had a probability of 0.15, all coming from that table that was given to us. And then 60 had a probability of 0.35. So this sets up our calculations for variance. So what I did is I just wrote a setup for this piece for each of the parts of our table. And now what sigma tells us to do is we want to add them up. So I have that kind of set up there. I'm going to add those up, and that is going to give me variance. So with that, let's go to a calculator. And let me kind of bring that down there, and let's get typing. Okay, let's see if I can format this a bit so we can see it all together. It's not going to be the prettiest, but we'll just do this by hand once or twice, and then we'll be good to use technology for it. So I have the squared deviation times the probability plus, and then the next one. I'm going to go ahead and type these out, but feel free to skip ahead in the video until I get to that answer. In fact, I'm going to pause and type so that I don't mess anything up. Okay, and I'm back. I could feel myself starting to slip a bit of making errors. So have everything typed in, and I could kind of double check that everything's matching up in terms of formatting. Across those addition symbols, the setup should be the same. It's just the numbers are changing. And with that, we're getting a variance of 104.04. So if we needed the variance, we would be all done. But most often, we want to go a step further to get standard deviation. And for standard deviation, we want to take the square root of the variance. So with this, what I could do is with this calculator, I could go ahead and press enter, and it's going to save my work up above. And then I'm just going to go square root and press this little answer button. This rounded nicely to 2 decimal places, but sometimes these can get messy. And again, you want to keep it as accurate as possible for as long as possible. But this one isn't too bad. But that's what I would typically do, is kind of save that answer and then go square root and have it grab that accurate answer. And we're getting a 10.2. Okay, so that's how we would do the calculation by hand. I find that table just kind of helps me organize everything before I start typing into the calculator. It is nice to put everything into the calculator in one go. I have seen students round as they go with this, and it ends up to an incorrect answer because especially with the squares and square roots, that error is just going to get thrown off. All right, interpretation. Let's talk about how we would interpret this. And what I'm actually going to do is take this and go back up above to our sentence where I said the cafe can expect to sell about 47 cups of coffee in a day. And the standard deviation tells me how we expect that to change on average. So I'm going to go ahead and add on here. The cafe can expect to sell about 47 cups of coffee in a day. And on average, this will deviate by about 10 cups of coffee. So that's a format we can use for putting together our expected value and standard deviation. So in the next video, I'll show a staplet, but this is what's happening in the background. Again, expected value can be done by hand fairly simply. And then standard deviation is a bit more involved, and we'll definitely use technology to help out with that, if anything, to check our answers if we do work by hand.